There's a number sitting inside a NOAA forecast update right now that has never once appeared in 75 years of ocean temperature records. And it's the reason scientists studying California's coastline are using language they don't reach for casually. Let's start with what NOAA actually confirmed. The Climate Prediction Center's El Niño team has been tracking daily sea surface temperatures in the Niño 3-4 region, the patch of tropical Pacific Ocean that serves as the standard benchmark for measuring El Niño strength. And those readings had been running dramatically above the 30-year average for months now. As of mid-August, NOAA put the odds at greater than 90% that this event becomes a very strong El Niño during the Northern Hemisphere fall and winter, and the odds sit at 69% that it ends up exceeding every El Niño on record dating back to 1950, when comprehensive tracking began. Michelle Leroux, the ENSO team lead at NOAA's Climate Prediction Center, has described the team's confidence in this outcome as having grown significantly as the numbers have continued climbing through the summer. By the way, if you'd like specific weather forecasts for your region or city, please leave them in the comments. I'll answer them individually as time allows. Also, if you like the video and subscribe to my channel, you'd be very grateful. Now, let's move on. Here's why this particular event stands apart from the strong El Niños people might remember. Every previous El Niño in the historical record developed against a cooler global ocean baseline than the one this year's event is forming on top of. Global ocean temperatures right now are already running warmer than at any point in recorded history, independent of El Niño entirely. Stacking a potentially record-breaking El Niño on top of an already unprecedented baseline is a combination scientists say has simply never been observed before, and it's part of why some researchers studying the event have suggested 2026-2027, or both stand a real chance of setting new global temperature records once El Niño's own warming effect layers on top of that already elevated baseline. Let's talk about what this actually means for California specifically, since the abstract global numbers matter less than what shows up on the coastline itself this winter. The most immediate, most measurable impact scientists have already quantified involves sea level, and the mechanism is worth understanding rather than just the headline figure. El Niño doesn't just warm the surface of the Pacific, it physically expands the water itself, since warmer water takes up more volume than the same amount of cooler water. At the same time, the weakened trade winds associated with El Niño allow that warm, expanded water to pile up against the west coast instead of being pushed westward across the Pacific the way it normally would. Daniel Swain, a climate scientist with UC Agriculture and Natural Resources, who has spent years cataloging California's floods, droughts, and storms, has estimated this adds up to roughly 6 inches of temporary sea level rise along the California coast this year, specifically attributable to El Niño. That 6 inches doesn't arrive in isolation either. It stacks directly on top of the sea level rise California has already experienced from long-term climate change, which ranges from roughly 6 inches to a full foot depending on the specific stretch of coastline, accumulated gradually over the past century. Add those two numbers together, and communities up and down the California coast are looking at total sea levels this winter, potentially a foot or more above what would have counted as a normal baseline a generation ago, concentrated into exactly the months when the state's biggest winter storms typically arrive. Higher baseline sea levels change the math on ordinary storm impacts in a way that's easy to underestimate. A routine winter storm surge or a routine set of large waves now reaches meaningfully farther inland and pushes seawater into storm drains, infrastructure, and low-lying neighborhoods that would have comfortably handled that same wave energy under normal conditions. Researchers at the Scripps Institution of Oceanography have presented modeling specifically illustrating an increased likelihood of high wave events tied to this developing pattern. And that combination of an elevated baseline plus intensified wave energy is precisely the mechanism behind the kind of dramatic coastal flooding and erosion that made headlines during past strong El Niño winters. It's worth explaining exactly how a patch of unusually warm water thousands of miles offshore in the tropical Pacific translates into actual weather changes along the California coast, because the connection isn't as direct as it might sound. El Niño's warming reshapes atmospheric circulation on a genuinely global scale, weakening the trade winds that normally blow steadily from east to west across the equatorial Pacific and, critically, shifting the position of the Pacific jet stream, the high-altitude river of fast-moving air that steers storm systems across the entire west coast. Under normal conditions, that jet stream tends to sit farther north, often directing the bulk of incoming Pacific storm energy toward the Pacific Northwest instead of California. During a strong El Niño, the jet stream typically shifts south, pointing more directly at California in the southwest, which is the fundamental mechanism behind the storms and flooding rains a significant El Niño event can deliver. The genuine complexity researchers are still working through is exactly how reliably that southward shift translates into actual accumulated rainfall once storms arrive, since the same broad pattern shift can still produce very different outcomes on the ground depending on how individual storm systems track, cluster, or fail to fully materialize within that generally favorable setup. It's also worth looking back at how the last two genuinely strong El Niño events played out in California, since the contrast between them is exactly why forecasters are hedging on rainfall this time around. The 1997-98 event delivered such a relentless, sustained parade of storms that it became the benchmark most Californians over a certain age still remember most vividly, causing well over a dozen deaths and hundreds of millions of dollars in damage statewide as neighborhoods flooded from sustained atmospheric river activity. Just under 2 decades later, the 2015-16 event ranked among the strongest ever measured in raw ocean temperature terms, arguably comparable to what's developing now, and yet it broke that expected pattern in a genuinely unexpected way, delivering nowhere near the rainfall that comparisons to 1997-98 had led people to anticipate. That mismatch became an important lesson for the scientific community, one researchers are now explicitly pointing back to as they caution against treating this year's record ocean temperatures as any kind of automatic guarantee of comparably extreme rainfall. Now, here's the part of this forecast where scientists are actually being the most careful, and it's worth understanding why. For a long time, the working assumption for a lot of Californians was simple: strong El Niño equals wet winter. The reality, as researchers have been emphatic about clarifying at recent public briefings, is considerably more nuanced. A super El Niño significantly shifts the odds in favor of a wetter than normal winter, especially across Southern California, but shifting the odds is fundamentally different from a guarantee. Some researchers have pointed out that the relationship between ocean conditions and actual rainfall totals has measurably weakened in recent decades compared to earlier ones, which is forcing forecasters to account for a wider range of possible outcomes rather than confidently predicting one straightforward wet winter the way older, simpler models once did. The 2015-16 El Niño remains the clearest cautionary example here. It ranked among the strongest events ever measured in raw ocean temperature terms, yet it largely failed to deliver the dramatic rainfall increase across Northern California that comparisons to the 1997-98 season had led many people to expect. What it did produce instead was record-breaking beach erosion up and down the coastline, driven by that same combination of elevated sea levels and intensified wave energy that scientists are now flagging as close to a near certainty again this year, regardless of exactly how the rainfall forecast plays out. In other words, even in a scenario where the anticipated parade of soaking storms doesn't fully materialize, the coastal flooding and erosion risk tied directly to sea level and wave physics remains a serious threat baked into the ocean mechanics of this event, largely independent of the rainfall question. There's a marine ecosystem disruption tied to this pattern too, one that reaches into the coastal economy and food chain directly. El Niño disrupts the cold, nutrient-rich upwelling that normally sustains California's coastal marine ecosystem. Species like squid, anchovies, and sardines get pushed farther north than usual as that cold upwelling weakens, and researchers have documented species considerably more associated with warmer tropical waters, including hammerhead, tiger, and bull sharks, appearing off California during previous strong El Niño events. Past events have also coincided with serious documented harm to seabird and marine mammal populations along the coast, casualties of an ecosystem suddenly running short on the cold, nutrient-dense water its food chain depends on. Preparation is already visibly underway across the state, which offers a useful window into how seriously officials are taking this specific forecast compared to a routine seasonal outlook. San Diego has convened a dedicated working group, bringing together representatives from every city department specifically to prepare for the range of weather-related emergencies this winter could bring, with officials flagging the need to closely monitor creeks, rivers, and aging stormwater infrastructure, including century-old dams that weren't necessarily engineered with a compounding, climate-amplified El Niño event in mind. Farther north, coastal communities have already been building precautionary flood defenses well before winter officially arrives, a visible sign that coastal California isn't waiting for the first big storm before starting to prepare. If you live along the California coast, the clearest, most consistently repeated message across every briefing and official statement on this developing event is that the physical mechanisms driving coastal risk, elevated sea levels stacking on top of existing climate-driven rise, and intensified wave energy layered on top of that elevated baseline, sit close to a near certainty this winter, regardless of exactly how the broader rainfall forecast ultimately plays out. The rainfall question carries genuine, honest uncertainty. The coastal flooding and erosion risk tied directly to sea level and wave physics does not carry nearly the same level of uncertainty. And that's exactly why California's coastal communities are treating this as a serious planning priority months before winter's first storm ever makes landfall.